of the things when I had you guys do that triangles facts list with the letters and the word triangle. Some people talk specifically about like the classification of triangles by angles. There are right triangles, there are obtuse triangles, there are acute triangles, and those are named for the type of angles that they have in them. So we know that different types of angles in geometry we studied: right, acute, obtuse, that type of thing. Straight angles, which is a straight line, or 180 degrees. We maybe take a different approach than we saw previously in geometry to angles. Like in geometry, it was like you could have an angle just anywhere out in space, right? You just need a shared vertex and two rays, and then you got an angle in between them. We are going to put all of our angles in algebra now because we want to look at these angles through algebraic perspective or lens. We're going to put them in something we call standard position. So all of your angles will be drawn the same way. Okay, you'll start with a coordinate plane. The angle's vertex will always be at the origin. Okay, so 0, 0. Then you have what we call an initial side. So the initial side always goes towards the positive x-axis. If you're drawing an angle in Algebra 2, it will always go to the right on one of its sides. The other side, is what we call the terminal side. And this is where I start opening up my angle. So imagine I'm an angle like I'm like 20 degrees, then I'm 70 degrees, I'm 180 degrees, and I can even be more than 180. Okay, I could be 270, or I could come all the way back around and be 360 if I had done a full rotation. And I can go around again if I want. So this side over here, this is called the terminal side. And a lot of what we do in class is going to be trying to decide which quadrant is your terminal side in. So it's really also helpful if you know your quadrants. Remember, the positive quadrant is quadrant 1. And then you go counterclockwise. Here's quadrant 2, quadrant 3, and quadrant 4. I oftentimes use Roman numerals. That's pretty standard for quadrants, but if you use the numbers 1, 2, 3, 4, that's fine with me too. So a lot of times when I'm grading an angle, like if you're being asked to sketch an angle, I'm checking to see that your terminal side is in the correct quadrant. Notice that there is this little red arc right here. That's really important as well when you're drawing an angle for me. It does not mean the same thing in geometry like a congruence arc because there's nothing for it to be congruent to. It's just telling people like what direction you went, because I could have opened my terminal side clockwise. It could have went the other direction. And it also tells me like how many rotations my angle made around the origin. So like I potentially could take that terminal side, go around once, and then go back to that spot. Or I could go around 3 times and then to that spot. So you might see like spirals in there too. So we have what we are now going to call positive and negative angles, which if you really like geometry and you're always thinking about geometry, this part might be like a little bit confounding to you. How can you have a negative angle? Well, it's just talking for us on the coordinate plane about the direction that we're going to open. So positive angles open counterclockwise. So think about it as like, you got your initial side on the positive x-axis, you got your terminal side. Counterclockwise would be opening in the order of the quadrants. I go through quadrant 1, then quadrant 2, quadrant 3, and finally quadrant 4. If I'm negative, I open in the opposite direction, so we would call that clockwise. And then I just drew a quick sketch of a positive. So that looks like the one I had on the first slide. I would just copied and pasted it. And then I have a negative. So now that little red arc, that's an important part of your drawing, so I can see that you understand directions of angles. If we wanted to talk about like estimating the measures of these angles, when you're at the positive x-axis, this is like 0 degrees. And then if you go through quadrant 1, you're at 90. And then 180, of course, if you want to label the others, 270, and you're back to 360. What would you estimate this angle to be? Tell your neighbors what you think that angle is. This one right here. I'm hearing answers like 120, 135, 125. Yeah, anything between 90 and 180, right? If I'm asking you to just estimate that, you don't know exactly where it is. Okay, but it's between 90 and 180. If we were going negative, this would be 0. And then if you go clockwise, instead of being 90, it's negative 90, negative 180, and then negative 270, and then this would be back to negative 360. Now estimate, just tell your neighbors what you think that measure could be as a negative angle. Maybe I'm hearing these, negative 230s, negative 240s. Any of those are fine as long as it's in the range of negative 180 to negative 270. And I like that some people are going closer to 270 because it looks closer. Okay. So isn't that interesting? Do these two angles without the red arcs really look like the same angle?
Yes.
Yeah, but then depending on which direction the arc goes, we have a different name for the angle, right? One of them is 120 degrees and the other is a negative 240. So that brings us, I think, I might do some examples with sketching, but that's going to bring us to our next concept after the examples, where you can have the same angle like we have on the board right now, but it can have different measures. So it can be named differently in terms of its size. But before we do that part, we'll do a couple of quick examples. Draw the angle with the given measure in standard position. And what quadrant does the terminal side lie in? So we're going to do negative 120 and 400. I'm going to give you just a little bit of time right now to kind of jot down what you think that angle will look like. Okay, so remember, all of our angles are going to have an initial side on the positive x-axis. You're going to pay attention to whether your angle is positive or negative. Each quadrant is 90 degrees. And see if you can draw the initial and terminal side of your angle. And also remember to show me the direction that your angle opens. And then once you get yours drawn, remember, try to name which quadrant you think that's in. The most important part would be, can you get your terminal side in the correct quadrant? Okay, if I were doing negative 120, remember, my initial side is going to start towards the positive x-axis, so I got that part down. I'm going to do a negative angle, so I'm going clockwise. Okay. And I want to get to negative 120. So the negative y-axis is negative 90. The x-axis negative is negative 180. And so I'm somewhere in between there. That means my terminal side must be in quadrant 3. piece I would add, show the direction of my angle. For 400, well, I can kind of skip over, I've got my positive x-axis initial side. I can kind of skip over all 4 of the first quadrants because I know when I do a full rotation, I get back to 360 and it's more than that. So now I just have to think about, okay, in which quadrant will it be after 360? So if you want to keep going, you can think about 360 plus another 90. This would be 450, right? And so obviously 400 is somewhere in between there. Okay, so that would be your terminal side should be in quadrant 1. And make sure that you drew the direction that your angle opens. So you're going counterclockwise. You're going to start going like through the quadrants in their order, 1, 2, 3, 4. And you did a whole rotation. That was 360 degrees right there. And you went a little more. If you only draw the little red arc in between the 2 sides, then you're showing me a 40-degree angle between 360 and 400. Okay, but to show me the 400-degree angle, you have to have that spiral. Okay. Any questions about sketching? Okay, so remember, just really quickly, I'm going to flip back to, flip forward. I'm going to flip back to, this slide right here. This slide right here when we were talking about like naming the angle and I showed you a positive and a negative, but we said, hey, that's kind of interesting. It's really the same picture. It's just that the red part is different. So we could name the angle a different measure depending on how we were looking at it. So those angles are called coterminal. And so I make sure I write something about coterminal angles down in my notebook. Coterminal. This is really, really important as we get into trig in section 9.3. You oftentimes have to start a problem because it's not between 0 and 360 by finding a coterminal angle. So coterminal angles are angles that share a terminal side, meaning they have the same terminal side and everybody has the same initial side, so they're really the same angle, but they have different measures. And I drew 3, copy and pasted, 3 images that look exactly the same. I'm just going to show like how we could have coterminal angles. Maybe this angle is that 120 degrees, right? Maybe this angle is like the last one that we sketched. We went around one time, so there's 360, and then we did 120. So 360 plus 120, that would be a 480 degree angle. Or maybe instead of going counterclockwise, we went clockwise. Then this angle would be negative 240. A 120 degree angle, a 480 degree angle, a negative 240 degree angle, they all look exactly the same, aside from the spiral, right? So like you guys know from geometry, you don't normally show the direction that the triangle or the angle opens. Okay, we do when we're sketching the angle specifically, but it's all the same angle. Okay. So here's how you find coterminal angles. Here's how you find the coterminal angles. Coterminal angles just have a difference of 360 or some multiple of that, right? If I'm an angle, here's my initial side, and I open to be 120, and I want another angle that's the same angle but a different measure, I could just add a rotation, or I could add 3 rotations, or I could subtract rotations, and I'm the same angle, right? I keep looking the same way. So plus or minus 360 from your angle. So here's an example. You'll have some problems like this in the homework. Find one positive and one negative angle that are coterminal with the given angle. So if I were given negative 100, well, to find a positive coterminal angle, I would add 360. 260 degrees is the same angle as negative 100. One is positive and one is negative. So I got my positive coterminal angle. Since this is already negative, to get my negative coterminal angle, I'll just go back to this original one, negative 100, and subtract a full revolution. Negative 100 minus 360. That's what? Negative 460. Also the same angle as negative 100. And like truly there's infinitely many answers. Like Ryan could say, I'm going to do negative 100 minus 360 minus 360 minus 720. And he would give us negative 820. That's also a coterminal angle. I'm going to guess most of you give me these angles because you don't want to do extra work, right? You're just going to add a 360 and subtract a 360. Okay, which is fine. In fact,
you can't use negative 100?
Negative, so you want a positive that is coterminal with negative 100. So negative 100 is the angle, 260 is the same angle but positive. And then you also want one that's negative with this angle. So it's already negative, then you have to subtract and get another negative one. Yeah. Okay. What about 575 degrees? What would you guys do to get the positive coterminal angle? Okay, you could in this case. Can't you subtract 360 and get a positive? Yeah, you say 215? Okay. So one way to do it would be 575 minus 360, which Jacob is telling me is 215. Or couldn't I do 575 plus 360? Would that also be okay? Yeah, that's going to be 5, 3, 1, 935? 935. Okay. Either one of those is fine for positive. Okay. If you wanted to get the coterminal that's negative, if you start at 575, so this would be like my positive coterminal angle. If I want the negative coterminal angle, you know, if I subtract 360, we already know from Tommy that that's still positive, right? So then I just have to subtract 360 again. So you may have to add or subtract 360 lots of times to get to the sign, the positive or the negative. Did anybody do that? What is 215 minus 360? Negative 135? Negative 145. Thank you, Jayla. You only need one of these answers. But like Will can have 935, Bo can have 215, and then both of them are going to get credit for having a positive coterminal angle. You might think like Tommy did, if I just subtract it twice, then I'll get my positive and my negative, so maybe that's less work. Okay, so if you want to think smarter, not harder, that's an option. Okay. Any questions about coterminals? Okay, your homework assignment is in the textbook, and I also have this half sheet that I'm going to give you. We're kind of on this half sheet doing a little bit of review of the special right triangles, and we're also doing a little bit of working ahead for section 9.3. So we're kind of like in the middle doing this angle work, but we're getting a little bit of review and a little bit of prep for section 9.3 at the same time. So it says label the sides of the special right triangle. You're using like what you know about the ratio of sides for 30, 60, 90, and 45, 45, 90. And then once you get them labeled, do all the trig functions. So at some point you'd like to have that done. We're really going to get into the business of this later next week when we do 9.3, but it is a good review of the SOHCAHTOA work we've been doing. So you can choose to work on the pink sheet, you can choose to work on the book assignment if you like. Any of those are okay with me.